Welcome to Streamwork Makes the Dream Work. Streaming analytics is hard, but it doesn't have to be. Dataflow simplifies it for you. You can start today, and you don't have to be a developer. We're going to cover 3 topics today. How do I start? How do I scale? And how do I optimize? But firstly, who are you? Someone with data in your title, data engineer, data analyst, data scientist. Someone who knows that real-time data is the key to unlocking new experiences. Someone who wants to start using the newest features and isn't afraid to use some of the products that we are going to be showcasing today. And someone who might be familiar with SQL. Python and Java are a bonus, but not required. My name is Mehran Nazir, and I'm a product manager with Dataflow. Before we dive into the presentation, let's introduce Beam and Dataflow for our newcomers. Beam and Dataflow work together. Beam is the open source SDK used to express your data processing pipeline, while Dataflow is the execution engine. Beam has an open source programming model by the Apache project, is a top Apache project by developer activity, includes a unified backend streaming model. So for folks that are coming from the Lambda world that have to maintain 2 different systems, you just have one, and offers a unique flexibility with runner and languages, meaning you could write your pipelines in the SDK of your choice with the desired backend of your choice. Dataflow, on the other hand, is an execution engine that runs Apache Beam pipelines. It's fully managed and serverless and can scale to millions of QPS with no management and no tuning. It offers accuracy with exactly 1 streaming guarantees and offers the separation of compute and storage with our shuffle and streaming engine services. So let's get into this. How do I start? To motivate this journey, we're going to take the perspective of a data scientist named Serena. Serena is a data scientist that analyzes data produced by data pipelines. She creates and maintains reports and dashboards, and sets up and maintains the company's data architecture. Some of the tools and skills she has include SQL, Python, in particular libraries like scikit-learn, pandas, matplotlib, and she likes using Jupyter notebooks to prototype and explore data ad hoc. But Serena's tasks come with challenges. She has to run these analyses on a scheduled basis, whether that be daily, weekly, monthly, and that creates a fair bit of manual toil. She has to interface with a number of different production systems, some of which she's not familiar with. And sharing pipeline code is manual and subject to human error. And then if data doesn't arrive on time, she doesn't have the skills to optimize and troubleshoot if necessary. Serena discovers streaming analytics with Dataflow, but in taking a look at it, she's immediately inundated with a lot of new information. She has to learn about a new Beam programming model. She has to understand what runners are, hearing terms like Dataflow, Flink, Spark. She's new to concepts like windowing, watermarks, and triggers. And ideally, she'd have a sandbox environment to test these concepts. Enter Jupyter Notebooks, which is perfect for her use case. She's familiar with them, and it allows her a place to learn about Beam concepts as she iteratively builds her Beam pipeline in a safe environment. Usually, notebooks have been good for analyzing batch data sets, but Dataflow has built new streaming extensions for notebook environments. Interactive Beam will bring new functionality that allow you to record sources, as well as interactively explore intermediate data transformations called P collections. This will help new learners pick up the basics of Beam, but not only that, it'll help experienced developers prototype pipelines step by step in a read, eval, print loop workflow. So let's see this in action.
To get started with Beam notebooks, Serena will navigate to the Dataflow console, and using the left-hand panel, navigate to the notebooks page, she'll see a list of the notebooks she's created, specifically with the Apache Beam environment. And if this screen looks familiar to her, she'll realize that this is actually identical to the AI Platform Notebooks interface. Beam Notebooks is built on top of that platform, meaning any features available in AI Platform Notebooks is also available through Beam Notebooks. She'll click on the New Instance button at the top, which will show an option for an Apache Beam VM. What this VM will include will all the necessary Beam libraries and packages for the interactive capabilities, as well as some examples that we'll go through in just a moment. You have the ability to select your region, your zone, a network if desired. And once I'm ready, I can hit create. That process takes a few minutes to initialize. So what we'll do instead is to navigate to a Jupyter Lab instance that has already been created for Serena. So I'm going to click on the Open Jupyter Lab tab, which will navigate to the Apache Beam Notebook experience. And what you'll see when you first start is a README that includes a directory of examples. We've pre-populated the Beam containers with 4 examples that successfully build on one another. The first one is a word count that demonstrates a simple batch pipeline. The second example is an extension of that into streaming, where as opposed to reading from a batch data source, it is reading from a streaming PubSub topic. And the third example is a more advanced streaming use case where we are looking at taxi ride data coming from New York City. And then lastly, we have a notebook that shows how you launch a Dataflow job from the notebook environment. So as I enter the directory of examples and really focus my attention on streaming word count as well as the Dataflow word count, I want to level set the 5 things that Serena is really looking for in her first foray into streaming. She wants to learn 5 things. She wants to learn 1, how to read from a streaming source. 2, she wants to better understand windowing and how to explore that data in the context of Beam. 3, she wants to learn how to write that to a streaming sink. 4th, she wants to see what that graph will look like, that topology, what it will look like when it's submitted to the Dataflow runner. And then lastly, she wants to know, again, how can she launch what's created in the notebook environment into the Dataflow service. The streaming word count example is a good starting point for understanding how she can do that. So the first thing she'll do is obviously she will import these libraries, all the relevant ones for Apache Beam, as well as some other utility libraries. And after that, she's ready to start setting up options to create the streaming pipeline. The next cell that she'll see is something she's not familiar with, called an interactive option called capture duration. What that allows you to do is set the data capture duration for your source recording. It can be set in terms of seconds. It can also be set in terms of size. But again, gives you the ability to assign how much data you want to be able to capture from your streaming source. Again, given that streaming sources are infinite, this allows you to allow a cap for that. Another important option that we've also introduced for streaming data is around the ability to enable capture replay. What this will allow you to do is if you always want to see the freshest data, you could set this to false so that all the data is new. But as you might know, one of the difficult things about notebook environments in general is how do I recreate streaming experiments, especially when data is coming in all the time. The ability to reproduce experiments is already difficult. The ability to turn this to true allows you to, again, turn a streaming source basically into a batch and allows you to prototype on one data source to, again, set a constant in terms of the data that is being ingested. So now that we've talked a little bit about what you could do with source recording, let's go actually into the meat of this pipeline and actually start building it from the ground up. The first thing you'll see is I'm going to be able to read words from this PubSub transformation. I've outlined this cell, and you'll see that this read is essentially going to map to the transform name when I actually submit it to the Dataflow runner. The first thing I do when I see those words, I want to be able to windows those. I want to be able to assign each a specific time windows. And as you can tell from this cell, I am assigning them to 10-second windows. And what I want to do with each of those windows is count the number of occurrences of each of these words per window. And that's what the next cell will do. So now that I've basically created the first 3 transformations in my pipeline, I want to take a chance to actually now start understanding windowing and explore my data. So that's what I have the ib.show function. This again is a functionality that allows you to include window information as a parameter. And not only will you see the number of times particular words are being counted in a given window, but you'll also see the specific window panes that they are associated with. As I scroll down, you'll also see that I have the ability to also visualize data that is coming in through the streaming data source. And we've built a few helpful tools that'll allow you to visualize the distribution as well as the occurrence of these words in a more illustrative context. What I want to do now is take that word. Again, I want to be able to count based on a normalized set of counts and not, again, necessarily count based on capitalization. So what I'll create is a map function that lowercases each of the words. And once I've done that, I use the show function again to count the number of words that I'm seeing on each of these windows. And the last thing that we've created is a new function called collect, which allows you to cast that data into the form of a pandas data frame and allow you to interact with that data in a context that's a lot more familiar. So now that I've kind of taken a look at how to read from a streaming source, now that I understand what windowing is and how to explore that data, and I've now gotten a chance to do those things, now I want to start actually think about how do I launch it in the Dataflow service. And what I'll do here is I'll switch over to the Dataflow word count example. When I click on this, again, this is just repeating the word count examples from the initial examples, but I'll quickly jump into the interesting parts. Now that I am thinking about launching into the Dataflow service, I want to think about actually writing this data to an output data set. And by going through these specific cells, you'll see that I will write this to GCS after I've specified a few options. You'll see that I've now indicated a GS bucket, which will contain the output of this streaming data pipeline. And once I have created this, added this write transformation, which will write this to text file and write it to a specific GCS location, I want to now see what will this look like on the Dataflow service. That's where I'll use the ib.showGraph function, which will give me an example of what my topology will look like. And as you can tell, it's exactly as I've described it. You'll read data from a PubSub source that will cast it to a specific P collection called words. I'll count those and write them to cloud storage, but I'll also create a separate branch which will lowercase the words and count unique instances that are irrespective of capitalization. Now that I've, again, verified that graph, I can now use the Dataflow runner to run that pipeline. And when I run this cell right here, I can now quickly click here and navigate specifically to the job that I've written in the Dataflow console. And with that, Serena now has gotten the entire top to bottom with streaming data sources using a Beam notebook.
Serena doesn't only have to use notebooks. She can also use SQL to launch streaming jobs. Dataflow SQL, a GA capability, allows you to launch Dataflow pipelines from the BigQuery UI. She can select sources and syncs from PubSub to BigQuery to GCS, and has a visual schema editor to help inspect the data. Some of the cool things she can do with this capability include real-time dashboards with BigQuery, as well as create other sources for other streaming pipelines. Now that Serena has mastered the fundamentals, how does she scale? Her team wants to use streaming now for data transport, simple transformation needs, as well as real time analytics, but her teammates have different requirements. They all have different sources and syncs. Not all of them have programming skills, and they all prefer to work from different environments, whether that be the UI, the command line, or the IDE. The solution? Serena can use Flex templates, a feature that we have recently launched into beta. With Flex templates, she can turn any pipeline into a template that can be used by other teammates. Users can take that template and execute it with their own arbitrary parameters passed in. They can do this from the UI, from the command line, or by passing in a request with the REST API. We'll now go through a walkthrough of Flex templates, which will show how we containerize a Dataflow pipeline, building the Flex template itself, then launching it from the UI.
Before Serena can use Flex templates to share her pipeline with her teammates, she has to first author a pipeline. So we'll start our demo by looking at the pipeline she's authored. This is a Python template available online that is ingesting a stream of positive and negative reviews. And as you can look at the statistics helper function, it is returning URL, the number of reviews returned by a URL, an average score for those URLs, and the oldest and most recent version of those reviews. And if you look at the pipeline itself, you'll see it's a very simple read from PubSub, a transcription of bytes to string, as well as a parsing of the JSON message itself. It windows that data into given intervals that will slice that data in the specified window duration, group those URLs, and then run that statistic helper function. And as you can tell, there are a list of arguments that are listed at the end of the pipeline that are going to be used for passing in as a template parameter. So now that we've looked at the pipeline, we're going to use Docker to build that template. So I'm going to switch over to the shell window and copy and paste a build command. And what this is doing is building that pipeline into a container. This gcloud command is essentially roughly equivalent to authenticating into the Docker service, building that Docker container using the image, as well as pushing that to the Google Container Registry. And once we are concluded, you'll see that our pipeline has successfully been turned into a Docker container. So now that we have it in the container registry, we are one step short of turning it into a Flex template. Before we can do that, we have to create a template spec file, which includes the name, description, and input parameters. So I'll flip back to my text editor and see what this container spec file looks like. You'll see that it has a name, a description, as well as a name, label, and help text for the given parameters. What my parameters will include will be a PubSub input subscription, a BigQuery output table, as well as a user-specified window interval. As you can also tell, I can also create some validation around whether these specific parameters are optional or not. So now that we're ready to actually build a Flex template, I'm going to quickly copy and paste my Flex template command, and I will go back to my shell. And once again, I will use a gcloud beta command, which was recently created for Flex templates, and build a container. And what we'll see in just a few moments is successfully saving this container spec in this Flex template file, which I will be allowed to call in the UI. So I can copy and paste this directory right here and go back to the UI. So I'm back in the Dataflow console, and in the jobs list page, I can see at the very top a button for creating a job from template. I'm going to navigate to that, and I'll see that I have the ability to specify a name. So we'll call this Serena Teammate PubSub to BigQuery. and I have the ability to select a template. What you'll also see is a list of Google provided templates, which allow you to do some very simple things for streaming, as well as batch and utility functions. But for the sake of this example, we're going to focus primarily on the custom template. If you remember, we have a GS location for that Flex template. I'm going to copy and paste that into here. And once I've seen that validate. I'll see that the description that I specify in the container spec file is located here, and the required parameters are found right here. And now my teammates can now use the same template that I've created on behalf of Serena with the organization to, again, drive, standardize, and more broadly enable data flow for a streaming organization. And in the event that you do not want to confine this to the UI, you'll see at the very bottom, we have also the ability to create the equivalent REST as well as the equivalent command line. So again, if you want to be able to launch a data flow job from your own environment, you have the ability to also just do that directly from the UI and enable your organization to use Flex templates.
Serena has now solidified her data flow expertise, and she's been able to share it with teammates. The final mission for her? How does she optimize her pipelines? Serena needs various things to help understand what is happening in her data processing environment. Monitoring and observability tools, logging, statistics and counters, and alerts to know if pipelines fall behind or violate their SLOs. The great thing about Dataflow is we offer these tools right out of the box. We offer a rich observability experience that includes relevant time series metrics, logs, and configuration information. And we've also recently launched a managed pipelines view that helps you understand how your recurring Dataflow jobs are running and quickly identify if your datasets are not being processed in time. So let's flip back to the user interface for our third demo.
To demonstrate how we're going to use the new observability experience to optimize your data flow job, we're going to navigate to the data flow console. The first screen you'll see is the jobs list page, which again is a listing of all your jobs sorted by type as well as status and the ability to filter those jobs. We're going to focus our attention on a retail application that we've open source. What this application is doing is reading data from website and mobile apps. It is also collecting transaction information from on-premise systems like a brick and mortar location, as well as collecting information from inventory to track the inventory levels of a specific product. And it's joining that information and running computations. I'm going to click on that job. And as it's loading, I'll also mention that this application is fully open source. So I do encourage you to look at the source code for this application for yourself. The first thing you'll see is the job graph. The job graph is the data flow runner's interpretation of your business logic and presents this topology for you to, again, review the entirety of your application. As I've already mentioned, what this application is doing is reading from multiple sources, it's processing multiple streams of data, and writing to different sinks. At the very top, you'll see the read transformations. You'll see that it's reading a click stream of data coming from websites and mobile apps, a transaction stream, which is reading data from on-premise systems, for example, brick and mortar locations, and then lastly, a stream of data that is tracking the levels of inventory available. Each of these streams have respective processing buckets, and at the very end, you'll see after a number of different computations are made, as well as some counts, we are writing to a sink like BigQuery for the consumption of another team to run analysis, as well as to PubSub for consumption by other pipelines. You'll see a little bit of a little arrow next to some of these boxes, and what that's really doing is condensing a lot of information. When I click on the process clickstream, you'll see a pretty significant expansion with an explanation of what each of these steps are doing. Again, this is business logic that's been expressed by you, and you'll see things like clean data, mapping elements, filtering that data, as well as computing a count to see which products are selling the best. And then once that that computation is made right into BigQuery. But if I want to get a better sense for how specific steps are performing, I can click on that step. And what you'll see on the right here is step information, the information regarding to the throughput of that data, as well as the output collections. Again, you'll be able to identify specifically which steps might be problematic and dig a little deeper from there. And one last thing I'll say about the job graph in the specific splash page is you have a job info panel on the right, which allow you to collect important metadata about your job, including job ID, the STK version, location, specific information with regards to the metrics, the resource that's being consumed. This will have a direct relation to the cost of the pipeline itself, as well as the pipeline options if you've selected for your pipeline. We've recently announced a job metrics tab, and this is what we are referring to as the observability dash. And this is what you want to use to optimize your job, but also to diagnose issues that might arise. You'll see specific graphs that are in line, data freshness showing the watermark of your data and to identify whether data is falling behind for whatever reason. System latency, which will show again if there's a specific bottleneck in your system. You'll see an auto-scaling graph. This specific application is only showing one worker, so it's not really showing the dynamism of data flow. But if you have an application that is looking at multiple workers with varying degrees of volume, that will also show in the amount of workers that are being provisioned for your job. You'll also see the same throughput graph that we mentioned on a per step level, but what's very helpful about this specific table is that now you are looking at the entirety of your job, and now the ability to sort your steps by throughput, and then quickly identify specifically where you might have bottlenecks in your business logic. You'll see CPU utilization, which will also chart the amount of CPU being used by workers. And then lastly, you'll see a worker error log count, which again allow you to see where specific errors are occurring on your workers. I think another good tip here is you'll see that when I hover over the chart, I'll see a gray dashed line, which will also showcase itself in the charts above in CPU utilization. And what that allows you to do is very quickly draw a correlation between when an error might be happening and what might be happening on your CPU utilization, as well as your throughput. Another tool that I'll also mention in this is the time selecting tool. By default, you'll see 6 hours, but you can actually look back as far as 30 days. We'll just take a look at your data over the last 7 days. And what you'll see is a varying degree of throughput. Just as you would see as a retail application, you'll see varying degrees of volume of user traffic, and that's represented in this graph, in the throughput graph. Again, if you're more prefer to see the amount of data that's being written in terms of gigabytes in size, you also have the ability to select estimated bytes per second. And the last thing I'll also mention is we also have a logs panel that includes job logs, worker logs, and a direct integration with our job error reporting tool, which will allow you to do more meta-analysis on specific errors that might be causing a backlog in your processing. So in summary, what we covered today was ways the users can optimize your data flow pipeline using the job graph, job metrics, and the job and worker logs. But not only is it a crucial tool for optimization, but also for diagnosing problems. Data flow pipelines will always present challenges due to the shape of data and the always changing nature of data processing in real time. But the entire observability experience allows you to get that as quickly and efficiently as possible.
So let's summarize what we've covered today. How do I start? We can start with Dataflow with notebooks or Dataflow SQL. How do I scale? We can scale our knowledge in organizations with Flex templates. And how do I optimize? We can maximize the performance of our jobs with the new observability experience. But note that is only a fraction of what Dataflow has to offer. We can also start our journey into Dataflow with Google provided templates that I showed in the demo. For scaling, we have Shuffle and Streaming Engine, which can scale your job to millions of QPS with no code change required. You have tools to help optimize your pipelines even more. And if you're ready to go take your pipeline into production, we've published a brand new white paper on building production-ready data pipelines. To use Dataflow, you have to use the Apache Beam SDK, and to that end, there are lots of ways you can build on your Beam knowledge base. We have IDE exercises called katas, we have quick labs, we have code samples, and we have a retail application that's been open sourced, the same application that I presented in the third demo. And not only that, we have a thriving developer community in the Beam world. This presentation will be published alongside the recording. Now, I would strongly recommend using this as a reference for the beginning of your Beam and Dataflow journey. In case you want to check out what else is new in data analytics, we have dozens of sessions that are ready for you. But if you're interested in more on streaming analytics, I would recommend DA 101, Easy Access to Stream Analytics, and DA 209, Real-Time AI, showing some of our advancements with Dataflow and machine learning applications. Thank you for your time today, and looking forward to seeing you start your streaming journey on Dataflow.